is center of mass? So, the basic definition of center of mass is the location or locations where all the mass is effectively located. And you can find this center of mass in two main different ways. So, there's either the rigid objects or objects with varying density. Rigid objects are objects that have uniform density. So, this could be like a plate. A plate is has uniform density, assuming that it's symmetric all around. Um, and depending on your object, depending if it's varying density or rigid density, will depend how you can calculate for your center of mass. So, uh, so to get more into the specifics with your rigid objects, your formula for calculating the center of mass will be the sigma notation of your mass times the location of the mass over the sum of the mass of the masses. And we could write an I here. So what this basically says is that you'll multiply the mass of the object at that specific location and do that repeated addition till you have done it for all the masses included. And the similar with the denominator, you're adding all the masses within the specific object. Well, when you're dealing with varying density, the equation for calculating the center of mass does look a bit intimidating, which is your integral of x dm over the integral of dm. Now, for this video specifically, we'll only talk about rigid motion or rigid objects, but we'll get more into varying density in another video that you can find in my physics playlist. So to get more into rigid objects, let's look at an example. Now, this may look a bit weird because you've likely never seen an object just like this. But assuming that this is a realistic object that exists out there in the world, we place it on a coordinate plane so that we can have the position much easier to find. Um, Now, let's attach some masses onto this object for the sake of this problem. So let's say we attached a mass right here, and we said this mass is 4 kilograms. And we attach another mass right here, and we'll say this is 6 kilograms. Okay, now let's attach another mass right here. And this one will be 6 kilograms as well. Okay, so as you recall, the equation for rigid objects, so objects that have uniform density all around, is denoted as the sigma notation of the mass times x. And we'll add this I to imply that we do this repeatedly. And we set this over the sigma notation again of I to imply that we do this repeatedly for all the masses of the mass. Okay. So since we're given a coordinate plane, for currently we'll only look at the x component because we have to understand that when you find the center of mass, you're typically given an order pair. So your center of mass will say Cm is going to be the x and y. And you use this equation for your respective component. So it could be, in this case, since we're dealing with the x's, it would be our x component. The only difference is when you're solving for your y component, you just replace it with your y variable instead of your x. So here we'll say center of mass for the x component is going to be equal. So let's say this is 1, 2, so 2 units to the right. So we have 2 kilograms times 2. And typically you're given units, but in this case, we won't apply units, but it would be the same process. But here we'll just say 2 for implying that we go 2 units to the right. Plus, now look at the x variable here. The x is 0. We're still at the y-axis. We haven't moved right or left. So this is still 6 kilograms. However, we're multiplying that by 0 because we don't move right or left at all. Plus 6 kilograms. And for this, we'll just say we're at 1 unit. -1, 1, and 2. So this is multiplied by -1. All over. Then we add all the masses together. So we have 4, 6. So 4 plus 6 plus 6, which would give me 11 kilograms. Which would give me 16 kilograms. So 4 kilograms times 2 will be 8. This just goes to 0. And this just goes to -6. So 8 minus 6 is 2 over 6. Or to simplify, it's 1 over 8. So that's our x coordinate. So our center of mass is going to be equal to 1 over 8. Now we solve for our y component. So it's the same thing, but except for our x's, now we're doing our y's. So we'll do y cm is going to be equal to 4 kilograms. And then we'll say this is 2 units up, right? So this would be times 2 plus our 6. We'll call this -1. So I have 6 kilograms, -1, plus, again, 6 kilograms. But this time we'll say this is -3. So we go down -3. And then this is all over the addition of all the masses, which we previously calculated to be 16 kilograms. And then, so 8, this would be 8, and 6 times -1 goes to -6. This goes to -18. So this comes out to be, so the 8 and the 18 goes to -10. So -10 minus 6 is equal to -16 over 16, which just simplifies to -1. So that's our y component. So we can estimate that would be our center of mass would be somewhere right here. Now, the thing when you're calculating the center of mass, it's a bit it's a bit trivial in the sense that sometimes your center of mass will not reside within the object itself, and it seems confusing and weird, but that's physics for you. Physics is complicated, abstract, and it doesn't make sense at times. But this is the way you do it. This is how you find it, which is just multiply the mass times the component's position, depending if you're solving for the x or y component, and divided by the total mass of the object. Now let's take a look at another example. Okay, so with this example, let's imagine a lightweight rod of negligible mass is 1 meter long. So we'll, 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 we'll just represent this lining rod as just a line. Okay. And in this example, we're told on the left end, so we'll call this the left end, which is when x is equal to 0, has a small metal sphere with a mass of 2 kilograms. So let's say a mass sphere is on this end, and it's equal to 2 kilograms. And then we're also told on the right end of the lightning rod, there is a large metal sphere with a mass of 6 kilograms. So we'll say right here is x x is equal to 1. And we have another sphere, a bigger sphere, that is equal to 6 kilograms. And we're told to solve for the center of mass of this lightning rod. And remember, this is the same thing. However, because it's just a horizontal lightning rod, we understand we have no y component. So this is a much easier example than the first example, because now we don't have to worry about a specific order pair where we're worried about our y component, but we're just worried about x. So again, we're going to use the same formula, which is sum our submission our summative of our mass times the position all over the summative of the total amount of mass, and this is going to give us our center of mass for our x component. And we only have to worry about our x component because again, we're not given we're not given a y-axis, so this is just a one-dimensional plane. So our known variables is 2 kilograms, 6 kilograms, and the position. So we can do 2 kilograms, and the position is 0, plus the other object, which is 6 kilograms, times 1. And we know 6 plus 2 is going to be 8 kilograms, which is what we're told right here, where we're adding all the masses together. So anything times 0 goes to 0, so this just becomes 0. And then this goes to be 6 over 8. And that's our center of mass. And that's how you find the center of mass for rigid objects. It's just the repeated addition of the mass times the position of that mass